So you're not really gonna have to name these properties for me, but you will need to know how to use them. Reflexive means that, and we use some of these actually in geometry. Reflexive, something equals itself. Symmetric means that the equal sign can be flipped, right? You can flip it on either side of the equal. Transitive, if A then B, B then C, A then C, we used that a lot last year. Addition property means you can add the same number on both sides of an equation. Subtraction means you can subtract a number on both sides of the equation. Multiplication and division mean the same thing. Basically, whatever you do to one side of the equation, you can do to the other with addition, subtraction, multiplication, and division. That's what those mean. Substitution means what it means in the real world. If they equal each other, you can substitute them for each other. Okay? So you don't have to name the properties for me right now, but you do need to know how to use them. So we are going to use them in these examples here. Look at the first one. Solving an equation with a variable on both sides. Solving an equation with a variable on both sides. Hopefully you remember your Algebra 1. All right? So the rules are I can add and subtract across the equation. The goal of solving equations is to get all your variables to one side and all of your numbers to the other. Okay? I personally do it the easiest way for me. So if I am going to end up with a negative going one way and a positive going the other, I typically go the positive direction. That's just mine. Some people always move variables to the left and numbers to the right because that's what they want to do. It doesn't matter. You're going to get the same answer as long as you do it right. So for me, I would actually move my 8y over and then my 48 over. So remember, when you move it across the equal sign, you have to change it, all right? We're actually trying to zero it out on one side and get it to the other. And whatever you do to one side, you have to do the same exact thing. So whatever it takes to zero it out on one side, you have to do that exact same thing on the other side. So for this one, I am going to take my 8y. It is a positive 8y. I want to zero it out on this side, so I am going to subtract an 8y. Because I subtracted an 8y there, I must subtract an 8y on the other side. All right? These will cancel. On the right, on the left, I have 13 minus 8y. How many y's do I have? 5y. I am going to do the same thing to my 48. I'm just going to move it to the other side. It is a positive 48. To zero it out, I need to subtract it. Because I subtracted it on that side, I need to subtract it on this side. All right? Don't forget your rules. We just said what subtraction was. It's adding the opposite, right? So if I want to add the opposite here, I just say add the opposite. And that shows me that I have a negative 47 plus a negative 48. What is negative 47 plus negative 48? Yeah, negative 95. So don't forget your equal sign. He's right here. And then this is going to be negative 95. All right? Once I have all my variables to one side and all my numbers to the other, I simply divide. Okay? So I'm going to take this and I'm going to divide both sides by 5. Remember, when I'm talking about multiplication, I'm trying to get it to a 1. So I'm trying to multiply by the reciprocal here, or divide. Divide by 5 here means I need to divide by 5 there. Negative 95 divided by positive 5 is what? Negative 19. That is my answer. Can I double check and make sure I did that right? How do I do that? Go back to my original and plug it into absolutely everything. 13 times negative 19 plus 48 equals 8 times negative 19 minus 47. You can check your work with order of operations, and they should equal each other. All right? So go ahead and try check understanding 1, A and B, top of page 19. So we've been using the distributive property for a while. Number one problem with distributive property are positives and negatives. Just think of them as individually. So when you distribute across, you're distributing the whole thing. So when I look at this one, I have 3x minus 7 times the quantity 2x minus 13 equals 3 times the quantity negative 2x plus 9. You cannot, now I say this knowing that these are not like terms here, but if this was just a 3 minus 7 times this quantity, you cannot do this subtraction first. All right, I have people do it all the time. All right, you must distribute the 7 first. This is multiplication. Order of operation tells me I have to do multiplication before I do subtraction. So even if these were like terms, you cannot do that subtraction out here first. You are skipping your order of operations and you will mess up. The other thing I want to point out is this is a negative 7 you are distributing. The reason it's a negative 7 is because subtraction is adding the opposite. So I am not distributing a 7 here. I am distributing a negative 7. All right, this affects the inside of this parentheses when I distribute. So you must distribute the whole thing that's on the outside. All right, so the first thing I'm going to do is I'm going to distribute. I'm going to distribute the negative 7 to this first group. And I am going to distribute the positive 3 to this group on the other side of the equation. I'm going to leave the 3x alone, 3x. I have negative 7 times positive 2x, negative 14x, right? I have negative 7 times negative 13. That gives me a positive 91. And that side is done for now. We're going to continue a little bit, right? On the right-hand side, I'm going to distribute positive 3 to negative 2x is negative 6x. And then positive 3 to positive 9 is 27. Now, when I have something like this, I actually want to combine any like terms on the same side of the equation first. The other mistake that people make is they do the opposite when they are not moving across the equal sign. Hear me, okay? Do not, please, do not say plus 14 right here, okay? I have people do it all the time. They'll add 14 here and then add it to the 3. It's clearly subtraction, okay? The only time you change the sign is when you move it across the equal. If you are not moving across, just do what the sign tells you to do, okay? So for this one, I have 3x minus 14x. Positive 3 and a negative 14. Subtract and keep the sign of the larger absolute value. 14 minus 3 is 11. My 14 was a negative, so negative 11 there, okay? So this is going to be negative 11x plus 91. I cannot simplify anything on this side, so I can leave it alone. All right? And then you just move your variables to one side, numbers to the other. That's all we're doing here, okay? So for this one, I personally would move this across, but you don't have to. You can move the 6 if you want to. It's a negative 11. I'm moving across the equal, so I change it. I'm adding 11x. Negative 6 and positive 11 gives me what? Thanks, 5x, all right? And then I'm moving this 27 across. Minus 27, minus 27, 91 minus 27 gives me 64. They're giving us a fraction, all right? I have all my numbers to one side, all my variables to the other. I can go ahead and divide. 64 does not divide by 5. It actually won't even reduce. So if you're giving me a fraction, you can leave it as 64 fifths. Or if you're giving me a decimal, 5 goes into 64 12 times with 4 remainder, which is a 0.8. So you can say 12.8 here, if it'll let me write. All right. Questions on that one? Check understanding number 2. So first of all, they're nice enough to give you the formula. This is a trapezoid. So formula for a trapezoid is the area is 1/2 the height, base 1 plus base 2. All right. They want us to solve the formula for h. This comes into play. These are variable equations. So these come into play when you are in like a chemistry or a physics and you're solving for the same thing over and over and over and over. So let's say we always wanted to solve for the height and we had the bases. If you don't go ahead and set up the equation that way, if they've given you the area and they've given you the bases and you're always solving for height, then you're going to be constantly shifting around. If you go ahead and shift these equations, they're called literal equations when you do this, then when you have your science information, you can just plug it in and your answer will always be what you're solving for instead of having to back solve for it. So this is used a lot in your sciences, to just reset the equation up with a different variable. The variable it's set up for right now is area. They said, no, we want you to actually set the variable up for height, okay, for height. And so when you have something like this, you are literally just going to move everything around like you would if it were numbers. I will say you do not have to distribute here. You can divide by an entire group if you don't need to get something out of the parentheses. So if they wanted me to solve for base 1, I would have to distribute here, okay? Potentially, or divide by the h first and subtract. But when it's something like this where the height's already by itself, I don't have to worry about it at all. I get rid of my half and then I get rid of my group, okay? So the first thing I want to get rid of is this 1/2. How do I get rid of a fraction? Multiply by the reciprocal. In this case, it is 2. So dividing by the 1/2 is multiplying by the reciprocal. So I can multiply this by 2. I'll get rid of the 1/2. And I multiply that by 2. So now I have 2a equals h times base 1 plus base 2. All right. Now I need the h by itself. I can divide by that entire group. I can divide by base 1 plus base 2. All right. Cancel it out. Divide by base 1 plus base 2. That means that my height, which is what I'm solving for, equals 2a over base 1 plus base 2. All right. If I were solving for one of my bases, I would have to either distribute or get the h out. I would actually just divide the h out and do subtraction. All right.
Divide by like 1/2 h.
Solving an equation for one of its variables. It says solve x over a plus 1 equals x over b. For x, find any restrictions on a and b. So let's first talk about restrictions. Why would there be restrictions on this? Why would I have restrictions? The only restrictions here are that a and b cannot be 0. A and b cannot be 0. What we see at first. We'll have another restriction at the end here. So a and b cannot be 0. And that's from the initial one. And then when we have something like this, we actually talked about this a little bit in Algebra 1. There is a way to get rid of my denominators here so that I don't have to deal with fractions, right? There's a way to get rid of denominators. Does anybody remember the shortcut to get rid of denominators when you have an equation like this? Multiply everything by its common denominator, actually, okay? So I have x over a. That's the denominator there is a. My denominator on 1 is just 1. My denominator over there is b. So what's my common denominator between a and b? AB, right? So I can take this equation, x over a plus 1 equals x over b, and I can multiply every single piece of it by my common denominator. Every single piece. All right? How does this help me? Well, this gets rid of all of my denominators. That's what this does. All right? So right here in the first one, I have AB times X over B. Well, my A's are going to cancel, and I'm left with just my B's, right? So I have, get rid of that little line, B times X, right? I didn't need to get rid of a denominator here because I didn't have one. 1 times AB is just AB. And across the equal sign, I'm going to cancel out my B's. And I have just AX, right? This is going to be easier to deal with than all of those denominators. So now if I'm trying to solve for X, right? It wants me to solve for X. When you're solving for this and you have multiple X's showing up, you need to get them on the same side of the equation, okay? So I am going to move this BX over. All right, it cancels here. I have AB equals AX minus BX, all right? So when you have something like this, you want your X's or whatever variable you're solving for all on the same side. Whatever they are, put them all together, all right? What can I do here? What can I do to get my X by itself? Yeah, distribution. Distribution actually goes both directions, right? Distribution means going into a FOIL, like into a parentheses, and pulling out of something. So X is common to both of those, is it not? So I can take an X out and I'm left with A minus B. This looks just like the B1 plus B2, right? At this point. If I'm solving for my X, just like I was solving for my H, I can now divide by the entire group, okay? So I can say divided by A minus B, divided by A minus B, right? And so my X is going to equal AB over A minus B. Now, when I finally solve for X, I actually have one more restriction here. What happens if A equals B? We have a problem, don't we? If A equals B? It's going to be 0 in the denominator. So my restrictions are A cannot equal 0. We already said that. B cannot equal 0. That's from these guys. And then A minus B can also not equal 0. Or you could say A cannot equal B.
So you can't simplify the AB divided by A minus B anymore?
Nope. You cannot. You cannot cancel those A's, or what would you'd end up with like 1, wouldn't you?
I don't know. I was just asking.
Yeah. All right, page 20. A dog kennel owner has 100 feet of fencing to enclose a rectangular dog run. She wants it to be 5 times as long as it is wide. Find the dimensions of the dog run. Okay, so when you have a picture problem, draw a picture. It makes your life a little bit simpler. So we have this rectangular dog pen here. She wants it 5 times as long as it is wide. So we're going to label our width here. We don't know what that is, but we know this length needs to be 5 times as long as the width, right? Make sense? All she has is 100 feet. That's all we have to work with. Fencing represents what? Area or perimeter? Perimeter, right? We're not going to like fill up the area with fencing. That would leave no room for a dog, right? So fencing is always perimeter. And so they basically are saying they want the perimeter to be 100 feet because that's all she has. And we want it 5 times the ratio to be 1 width for 5 times of length, right? And so anytime they say, I want the length to be 5 times as much, something like that, you're just translating that into algebraic expressions. 5 times as much, I mean, they actually say the word times in there, so that's multiplication, all right? 5 times as much as the width. So to find perimeter, we just 2 times the width, 2 times the length, right? Or you can just add them all up. So we could say 5W plus W plus 5W plus W. What am I going to get there? How many W's do I have? 12. And that should add up to how much fencing I have. How much fencing do I have? 100, right? And they were nice. They're going to give us a fraction of a fencing because that's easy when we're making a fence, right? What do I do? How do I solve for my width? Yeah, divide by 12. It is going to be a fraction, right? 12 is going to go into 100. How many times? 4 is going to be your remainder, right? So it goes 8 times with a remainder of 4. 4 over 12 is 1/3, right? 8 and 1/3, we are talking about feet, all right? Which one did I find? Width or length? My W, right? So in order to find my length, I need to multiply by 5, right? If it asks for dimensions, it wants both of them. So don't just give me one because you will not have given me the entire answer. So it has to be 8 1/3 feet, and then I'm going to multiply that by 5. Now, if you have it in fraction form, then you're multiplying. But if you have it in mixed number, keep in mind that's 8 plus 1/3. So there's actually a distribution that goes on there, which is kind of weird. So make sure that when you multiply 8 1/3, you don't get like 40 1/3 because that's wrong. Okay. So when I multiply, I'm just saying this because some people may not understand this. You are literally multiplying that. Okay. You actually have to multiply the whole number and the fraction. So you actually get 40 5/3. We don't want to leave an improper fraction and a mixed number at the same thing. So we're going to get 41 2/3. You actually have to pull it out. Now, to avoid that issue, you can leave this as an improper fraction and then simplify them both. So you could say 100 over 12 and 500 over 12 if you wanted to, and then make them both improper fractions at the end if you're going to confuse yourself by multiplying mixed numbers. All right. So your answer there would be those dimensions. 8 1/3 by 41 2/3 feet. All right, triangles. The lengths of the side of a triangle are 3, 4, and 5 for the ratio. So all this means is that just like if the ratio was 1 to 2, in a two-dimension, in like two lengths, they're giving you 3 lengths. So they're just giving you a ratio between the 3 lengths, okay? The ratio is 3 to 4 to 5. So they're telling us the perimeter of the triangle is 18. So that means that what they're telling you is there's a common number that is multiplied by those 3 sides that gives you the ratio of 3 to 4 to 5. We don't know what that number is, so we're going to assign it an x. So that's why they have said 3x, 4x, and 5x, okay? Because if they tell us it's a ratio, then you can multiply those numbers by the same number and get the actual length, okay? All they've done is reduce it to give you 3, 4, and 5. So when they give you a ratio like this, you're typically solving for that variable that you're multiplying those numbers by to get the actual lengths. It says find the lengths of the side. All right, so it actually wants you to find the side lengths here for the triangle that they are giving us. All right, so let's look at this. They have 3x, 4x, and 5x here. They have given us the perimeter of the triangle. Perimeter of a triangle is just like perimeter of anything else. You just add up the sides. So if I want the perimeter of this triangle, I'm going to say 3x plus 4x plus 5x. Why do I do that? Well, I know my ratio is 3 to 4 to 5. What I don't know is what I am multiplying by to get that ratio, okay? I don't know my actual x variable, but I know that the actual perimeter is 18. So I'm actually solving for the variable that I multiply my ratio by. What is 3x plus 4x plus 5x? 12x, all right? So I'm going to get 12x equals 18. Divide both sides by 12. And I'm going to get 1 6/12, also known as 1.5. I have solved for my x. I have not solved for my side lengths, okay? In order to solve for my side lengths, I need to plug in a 1.5 to these. Does that make sense? I've only solved for the number I need to multiply that ratio by. So 3 times 1.5 is going to be 4.5. That's a side length. 4 times 1.5, this one is going to give me 6. And 5 times 1.5 is going to give me 7.5. This is actually the answer. Those are my side lengths. The first thing I solved for was just the number that each number in the ratio is multiplied by. Multiplying by that number gave me the actual side lengths. And what that tells me is if I compared those three numbers, they are in a ratio 3 to 4 to 5. Okay? Just like if my x had been 2, and it would have been 6 to 8 to 10, 3 to 4 to 5. They reduce. All right? So try check understanding number 6. They gave you a different ratio and a different perimeter.